Yesterday, I spoke about electricity. It's just a pile of electrons, and Michael Faraday discovered that magnets have enormous amount of electrons on them. But we still have to harness the electrons to make it useful. Otherwise, it's just still electrons on the magnets. It's not so meaningful. So Michael Faraday realized that there are two mechanisms in playing. First of all, to generate electricity, you have to liberate the electrons on a magnet. How do you do that? You basically, so every single magnet has a natural magnetic field around them. We all know magnets have north poles, south poles, and they have this natural magnetic force. Why does this natural magnetic force exist? It's actually quite complicated. It is related to quantum mechanics, the natural arrangement of ferromagnetic materials. You have this thing called domain. I can't really remember domain of their electrons. So every single magnet has magnetic field around them, and if you disrupt the magnetic field using some especially metal electrical conductor, metals that are good in conducting electricity. When you use metals to disrupt the magnetic field around a magnet, and electrons will be generated around metals. So what do you do is you have metals, for example, a piece of iron rod, and then you keep disrupting the magnetic field in and out, and that is the way how you generate electrons, liberate electrons from the magnets. And this is practically what every single electric generation plant is doing. So if you go to Tanago National TNB, they are doing something like that. They are burning coal every single second in a giant, really hot furnace. And when you burn coal, because coal is a really great hydrocarbon, and it is highly flammable. When you burn coal, it releases so much of heat, and under the furnace, the water will be boiled so quickly and become a steam vapor. And steam vapor, as we all know, it is really hot, really high kinetic energy, so they move really fast, and they will be able to spin a turbine. And when the turbine is spinning, you put a magnet around the turbine. Well, actually it's turbine around a magnet. All right, and the turbine spin around the magnet incessantly, and then there will be lots of electricity will be generated, and then it will be transported via wires to the electrical tower, and eventually being transported to your home. Of course, I believe in electric generation plant, the magnet is just gigantic, huge magnet in order to generate that much of electricity to every single house. So this is what Michael Faraday discovered. You convert mechanical energy, kinetic energy from a turbine into electricity by spinning the turbine around magnets. And the reverse is also equally beguiling. Michael Faraday also discovered you could do the reverse. You could also use electrical energy to generate mechanical energy. Michael Faraday invented the electric motor. So what do you do is, in electric motor, you let the electricity flow, and then you have the electrical wire flowing the electricity, and then you put the electrical wire nearby magnets. Okay, when electrical wires move nearby the magnets will generate very strong magnetic field, and then you have north pole, south pole, so you put the same poles together, they tend to repel, and therefore they will move incessantly. This is practically how your electric fans are functioning. You have electric motor, You are converting electricity to mechanical energy, keeps moving all the time. And this is also why a lot of high school students, when you learn physics, you learn about something called solenoid. So you basically coil a wire around a metal, particularly ferromagnetic metal, such as iron or copper. You coil the wire around magnet solenoid, and then the magnet around metal, then the metal will becomes a magnet itself. You have generate poles, and then when you have poles, they repel each other. This is how things move. So these two mechanisms are actually inverse of each other. And this is, I think, the most fundamental earliest form of electricity being harnessed. But electricity itself is still not enough. In order for electricity to be useful, you need some customization. The obvious one, the simplest one, would be light bulb, or your electric heater. What they do is basically you pass through electricity into a certain part inside the light bulb or the electric heater. If I'm not mistaken, they are normally made of tungsten, one of the 118 elements in periodic table. So tungsten has a good characteristics. When electricity pass through them and they are being heated up very quickly, they release heat and light energy. That is basically how your electric heaters and light bulbs are functioning. And of course, more complicated things like television, air conditioners. How does electricity actually make moving images, generate cold and cool air? That is a bit complex. I'm not knowledgeable enough to explain. But other than the mechanism I've just explained just now, over time, actually, I believe about the same time as Faraday, there was another physicist. He was an Italian. I believe his name was called Volta. So he also discovered that when you mix certain chemicals, they release electrons rather quickly. For example, you use zinc, something like that, and then with chlorine. So Volta realized this is basically the mechanism of dry battery. So in a dry battery, what is happening? Why is a dry battery able to make your alarm clock move itself, ticking and also ringing when the alarm when the time when the time that you have set for alarm actually reaches? So in a dry battery, you will realize that inside there are chemicals, and then you have anion and cation. You have the positive one, electropositive metals such as zinc, 2+. They are prone to release 2 electrons. And then you have a cation. You have an ion, the electronegative element, such as chlorine. When they react, they release electrons consistently. And of course, nowadays, for example, your phone and my phone mainly use lithium. And why do we use lithium? If you study periodic table, we know lithium, the position is basically just a second period and first row. The third chemical element, the electronic configuration is 2 and 1. First shell contains 2 electrons and the second shell contains 1. So it's an extremely electropositive metal, and therefore lithium is so eager to release electrons every single time. So people use it as a battery for phone. In fact, if I'm not mistaken, the physicist who discovered and invented lithium battery, he won a Nobel Prize for that. So other than the mechanism discovered by Faraday, which you have to use a turbine and move things around magnet, this dry battery mechanism is another mechanism where you convert you convert chemical energy to electrical energy. Of course, it's not too efficient. You can't can't really use battery to power too many things. Last time it was just alarm clock or a small pocket calculator, and later on we have phone. But of course, recently we all know how powerful Tesla, the company, is. They managed to use really powerful lithium battery to power a car, and household appliances. We are still not using battery predominantly. We are still using the old school electricity generated by the plant. And then besides these two, the third one will be solar panel. So how does solar panel actually work? It is exactly similar with a dry battery. So solar panel is made inside solar panel. There is a layer that is made up mainly of silicon. So silicon, we all know, is a really ingenious, smart element, semiconductor. It has a feature whereby you can control when will it release electron. Especially when it is heated up, it will release electron, and otherwise it will not. All right, it is not too reactive, not too unreactive, and therefore humans are able to control it. So solar panel, how solar panel works is basically we have photons from the sun. So then when photons hit the solar panel, it is able to liberate electrons from the silicon layer. I think it's quite simple, but the tough part of solar panel is how do you engineer a really high quality layer of silicon so that a lot of electrons will be converted in a short span of time. That's why people often lament about how inefficient solar panel is. The conversion rate, the energy conversion rate is still less than 20% or even less than 10%. It is still not happening. So solar panel is another way to liberate electrons. The first one, just now I said, Faraday liberated electrons from magnets using the generator turbine around magnet. The second way is mixing chemicals, anion and cation, mixing them together, and they will release electrons. And the third one, solar panel, you leverage on photons from the sun to liberate electrons from the silicon layer within the solar panels. So these are basically how electricity works from my understanding, and there it goes. If you really think about it, human civilization has been existing for 5,000 years. The earliest days from Egyptian, the Sumerian, but as late as 17th century or 18th century, only we are able to harness electrons. So basically, electricity is something we take for granted, but if you look at a grand scheme of things, the entire history timeline of human civilization actually is very short. It's just 300 to 500 years at most out of the 5,000 years of human civilization. So it's just 10%. And before that, the 90% of the time of human civilization, people survived without electricity. And in fact, we all know how gruesome it could be. So this modern invention are really great. I will continue tomorrow. See you. Goodbye.